Hey, this is Miss Merle. This is the review video for the equations and data representations test. So if you guys have any questions, come ask whoever your teacher is, or ask me. Hope you guys enjoy it, and sorry, just sit tight because it's a pretty long one. So make sure you study and get ready for your test. Here's number 1 on our review. It gives us an equation, and it says that C is the total cost of T tacos, which you guys should like because apparently we all love tacos. So which table contains values that fit this equation? So like we talked about, we're going to take the T values and plug in where the T goes and make sure you get C. So I'm just going to start here with the F answer choice and start plugging in for the values. So the first one would be C equals 1.15 times 1, but instead of C, actually, we would replace that with 1.15. So 1.15 times 1, it does equal 1.15, so that one looks good. So I'm going to do the same thing. I'd do 2.30 equals 1.15 times 2. So again, I'm using this equation, which is C equals 1.15 T, but instead of putting these letters, I'm replacing it with the actual values here in this chart. So we have to see, does 1.15 times 2, does that equal 230? Yes, it does. So I'm going to do the same thing. 3.45 equals 1.15 times 3. It's important to try each and every one just to make sure that it works for every value. So we multiply that times 3. 3 won't. So that one worked. So the last one is 4.60 equals 1.15 times 4. So that one worked also. So all of my choices worked. So I know my answer is F. For number 2, it says which line graphed below best represents the table of values. So this one's going to be a little bit hard to see, but you basically remember that each line in this XY chart actually represents a point. So this point will literally be -3, 3.5. So that means we would go to the left 3 and then up 3.5. So I need to find a graph that has that point. So remember, when you graph points, I'm going to zoom into this one. Remember, you always start at the origin, which I believe is here. Here's the origin. I'm going to make a little red dot. Here's the origin. So we start at the origin. We're going to go 3 to the left and up 3.5. So 3.5. So actually that point does fall on this graph. So I know that part's good. My next point was 0, 5. So again, start at the origin 0 and then I go up 5. So that point is on the graph as well. My next point is 2, 6. So start at the origin and I'm going to go over to up 6. That point is on there as well. And then my last point is 5 and then 7.5. So start over 5 and then up 7.5. So actually it contains all of those points. So I know A is my answer. So far we've gotten lucky and it's been our first try. It's not always going to work like that. Also remember, I just wrote this here so I could find the origin because it's kind of blurry on my copy. So you don't actually draw that point on there. So just so you know. Alright, next question is on the next page. Number 3. George registered players for the Summer Soccer League. The table below shows the total number of registered players by the close of registration Friday at 6. So it says that 49 players are in this A division, and it's $20 a player to play. There's 54 in this next one, and it's $20 per player to play. And then there's 67, and it's $30 per player. So George deposits this much money he collected in registration fees, which expression can be used to validate his total. So that just means we have to figure out how did he get this. So actually, the way I like to look at it is how would I have solved this to get how much total money he collected. Well, we see that the first two divisions, these two divisions, both cost $20 a player. So we know they have that in common, whereas this other one costs $30 a player. So I'm going to start looking through my answer choices. The first one is 20 times, which we know we would multiply 49 times 20, and we would multiply 54 times 20 because it's $20 each. So it says 20 times, and then you add up the 49 and 54. So we add those up and multiply by 20, plus 30 times, because it's $30 a player, 67 because there's 67 total. That one looks like a pretty good answer to me, but I gotta check the rest. Would you add the 20 and 49? Would you add up? No, you wouldn't, because each player would have to pay 20. So I know that one's not a good choice. This choice, they added it and then multiplied. Which you do add it and then multiply, but the order of operations in this instance would make you multiply this first and then add it. That's why you need those parentheses like we had in F. So I don't like H. And then J, they added all of the players up and then added the registration up and then multiplied that. That actually wouldn't work because that would basically be charging each player $50 to play. So that one is not a good choice. So that's a good answer, F. So far we've gotten pretty lucky that our first answer has been right and we haven't had to check too much. Number 4. A software company employs 450 workers. It plans to increase its workforce by 8 employees per month. So this gives me a hint, 8 per month. So I know something, 8's going to be times multiplied by the variable because it's 8 per month until it's doubled in size, which equation can be used to determine M, the number of months. So M is that variable. We're going to be multiplying by the 8. So I know somewhere in my answer choice it has to be 8 times M. So this one has 8 times M. This one has 8 times N. This one does too, but not B. So I know B already isn't right. So basically right now it has 450, and then it's going to increase by 8 per month. So we have 450. Increase means add $8 per month until it has doubled in size. So we know our company wants to double. That means times 2. So I do 450 times 2, and I'm going to get 900. So something like this should be what our equation looks like. So I'm going to go back through my choices. This one, they're actually multiplying the 450 times the number of months, which is not accurate, so that's not good. The C answer, they're having you double. Well, that's not what's going to be doubled. The amount we want total is the doubled, which we already did. So this one's not right. So my answer is going to be D, which actually looks almost exactly like what I had written over to the side. But remember, when we add, it doesn't really matter which order we add in, so they just flipped it from what I had written. So there we go. So number 5. Which of the following statements best describes the data in the table below? So looking at our table, I kind of look at my numbers for a minute. Then I start reading through these and we'll see what works. The value of y is 3.5 more than the value of x. So basically what that is saying is 3.5 times, not times, plus the x value. Okay, so we're going to try that. because more than would add. So if I do 3.5 plus 1/2, that equals 4, and that's what they got. So far it looks good. So now I'm going to try it with this next one. So 3.5 plus 1 equals 4.5. Does that equal 5? No. So I already know F isn't going to work. So now I'm going to have to do the F, or the G answer. Okay, so G says the value of y is 3 more than twice the value of x. 3 more means I'm going to add 3 to something. Twice means I'm going to multiply by 2. So this is my equation for that one. So instead of x, I'm going to put in the 1/2 right there. So 2 times 1/2. Then I put the plus 3, because that's what we had here in our equation. So 2 times 1/2 is 1. 1 plus 3 is 4. So that one worked because we were supposed to get 4. Now I do 2 times, this time instead of 1/2, I'm going to put the 1 plus 3. 2 times 1 is 2, plus 3 is 5. And that's what I was supposed to get, so far that worked. I'm going to keep trying 2 times, I'm going to use the 3 this time, plus 3. That's 6 plus 3 equals 9, so that's what we got, so that works. 2 times 4 this time, plus 3. 8 plus 3 is 11. Look, that's what we're supposed to get, so that one worked. So that's my answer. If you aren't positive, you could go ahead and try the rest of these. 3 times the value of x increased by 1 would be 3x plus 1. That's your expression you would use, and then you'd plug in the x where the x goes, just like we've been doing. J, it says the value of y is 3 less than twice the value of x. So twice the value of x, and then 3 less means we subtract 3 from it. And then we take the x and plug it in each time and see if that works. But G is the answer for that one. The next one, number 6, Alyssa rakes leaves for her neighbors. She charges $4 an hour to rake leaves plus $7 to remove the leaves. She uses the equation below to calculate T, her total earnings, based on H, the number of hours. And then it actually gives us the equation already, so we don't even have to write the equation. The best part about reading this information right here, though, is to know what the T stands for and the H stands for. So we know T is the total earnings, and the question asks how much will she earn. So T is what we're looking for, so we don't know T. We do know, though, how many hours she works. So 7 plus 4 times. So we're going to be able to fill in the H with 3 hours and 15 minutes. So this is probably what tripped you up, is 3 hours and 15 minutes. We can't really plug that in. We have to make the 15 minutes into a decimal of hours. So we know, well, I know that there's 30 minutes is half an hour, and half an hour would be represented by 0.5. So 15 minutes is a quarter of an hour, and a quarter is represented by 0.25. So it would be 3.25. If you don't know how to do that, you could look at how many part. Remember, we do part over whole, like as our proportion. So we could do 15 minutes out of 60 total minutes. So we could use that fraction, and when we do and do top in the box, that would give you your decimal 0.25. So that's another way to do that. So this is our hours that we can plug in for the H. So I already rewrote the equation right here, so we're just going to fill in 3.25 for the H. So now we do order of operations, so we multiply that first, so 3.25 times 4 is 13, so then we just bring down the plus 7, so 7 plus 13 is 20. So my answer was C, $20. Next question. An average cheetah can run at a rate of 68 miles per hour. The relationship between a cheetah's rate and an average giraffe, which is G. So again, this information helps us know what the G actually stands for. So giraffe is represented by this equation. So they gave us the equation, and we know that G stands for giraffe. Based on the equation, what is the rate in miles per hour the giraffe can run? So we're looking for G, which is the giraffe. So we need to solve the equation for G. So remember, when we solve an equation, the way I do it, I draw a line down the equal sign. And then I want to move, oh look how I forgot to write the G whenever I brought my equation down. I look and I want to put the variable on one side, or the letter on one side, the numbers on the other side. So since my G is already on this side, I'm going to leave this part, the G part, on the left side, and I want to move this number to the other side. Well, remember, to move across the equal sign, we have to, basically, to pay to get across, you have to do the opposite operation. So right now, this is a positive 8 plus 8. So I have to do the opposite operation to move across to the other side. So I have to subtract 8. When I subtract 8, this cancels out to move to the other side. So what I do to one side, I have to do to the other side. So now I have 68 minus 8. Well, 68 minus 8 is 60. Then I didn't do anything with this 2.5G yet, so I just bring it down, 2.5G. So now I need to get rid of the 2.5 that's right next to the G, because I need all the numbers to the other side. So I have to figure out what operation is happening right now, which is multiplication, because remember, if they're right next to each other, that means to multiply. So the opposite of multiply is to divide. So I'm going to divide by 2.5. So this cancels out to make a 1. So I have 1G left. But what I do to one side of the equal sign, I have to do to the other. So I'm going to divide by 2.5 on this side. So now I'd be left with, I'm kind of running out of room, so this would be G, and then on this side I need to divide. So 60 divided by 2.5. Remember, when we divide, there can't be a decimal on the outside, so I have to move this decimal one place. Or if I move it on the outside, I have to do the same thing on the inside. So there's like a decimal hanging out at the end here. Well, we have to move it one place. So I'm going to add that 0. So my decimal will be back here behind the 600. So now 25 will not go into 6, but it will go into 60 2 times. 2 times 25 is 50. I subtract and I get 10. I bring down my other 0. 25 will go into 100 4 times. So I get 24. So G equals 24. So my final answer is B. Next question, the equation y equals, so they gave us this equation, I should probably mark that one, represents the charge a repair shop uses to determine y, the cost, so we know this is cost, for X number of hours, so X is the number of hours worked. What would be the charge for labor for 3 hours of work? So since this is hours of work, am I going to replace it for the Y or the X? Well, hours of work was what X stood for, so I'm going to replace the 3 where that X goes. So down here I'm just going to rewrite my equation, but instead of X, I'm going to put a 3 and then finish the rest of the equation. So now I am going to do order of operations, so I multiply first. 30 times 3 is 90. And then bring down the plus 25. So then I do 90 plus 25 is 115. So my y equals 115, which stands for the charge. So it's going to be $115. So there's that one. Number 9. The the number of games won by the Crows football team is twice the number of games won by the Bobcats football team, minus 4. So it says which table contains values that fit this equation. Well, they didn't give us the equation, so I'm going to have to write it. So the games won by the Crows football team is, and is tells us there's going to be an equal sign there. So I'm going to say the Crows football team is twice the number of games won by the Bobcats team, so twice the Bobcats, minus 4. So there's my equation. So now I just have to look at my table of values, and I'm going to plug in for the Bobcat and for the Crows and see what works. So first, I'm going to change my little pointer here. Here's Bobcats, here's Crows. So instead of this C, I'm going to put a 4 because I use C for Crows. So I'm going to put 4 equals 2 times. So instead of the B, I'm going to put the 4 for Bobcats. So 4 minus 4. So 4 equals 2 times 4 is 8. 8 minus 4. 4 equals 4. So far, that one worked. But I can't just stop with that. I have to try every possible option, every part of the table of values. For some reason, my 4 won't erase, so I'm going to have to write over it. So instead of this C, I'm going to replace it with a 6, because that's my next one. And then Bobcats is 5, because it's right here. So then I do 2 times 5 is 10. 10 minus 4 is 6. So does 6 equal 6? Yes, it does. So that one worked. Then I'm going to try the next one. Instead of C, I'm going to put an 8 equals 2 times 6, because I'm using this part of the table, minus 4. 2 times 6 is 12. 12 minus 4 is 8, so that one worked. And then my next one, I'm going to do 10 equals 2 times 7 minus 4. 2 times 7 is 14. Take away 4 is 10, and that's what they said it was going to equal. So actually F is what works on that one. So that one was pretty good. Next question's on the next page, I guess. Okay, this question, we have to use the graph and this graph and then answer the question. So he selected an orange paint color from the paint samples at the home store. The paint he chose uses a mix of red and yellow paint. So this shows us the red and the yellow. Which of the following colors did Jacory choose based on the description of the color mix from each paint sample? So when we read this first one, this paint is a mixture of 20% red paint and 30% yellow. Well, it says the paint is only a mixture of red and yellow. So if you add 20% plus 30%, is that going to equal 100%? Nope, it doesn't equal 100%, so that one can't be the answer. This paint is a mixture of 8 parts red and 10 parts yellow. So we're going to have to extend the graph 1 to 8 parts, and it would need to go up to 10 parts. Well, I can just tell you that when we look at this, I'm going to scoot up a little bit. When we look at it, our fractions are going to be 2 over 3. So we have 2 over 3. My next point is 4 over 6. My next one is 6 over 9. So if I look at those fractions, what do they all have in common? Well, they all reduce to 2/3. So let's look back. Let's look back at the 8 parts to 10 parts. Well, if you do 8 parts to 10 parts, will that reduce to 2/3? No, that doesn't reduce to 2/3, so we know, I did it again. We know that this one isn't a good answer either. This paint contains 2/3 more yellow than red. Well, it's actually 2 out of 5 are red, and 3 out of 5 are yellow. So yellow is not 2/3 more. So D is my answer. 40% red, 60% yellow. So 40 plus 60 does equal 100, and then we need to make sure 40% and 60% makes sense. So when you look back up here, you can see at 40% red, it's 6 parts yellow, so yes, that makes sense. So this one's pretty tricky actually, but that's how you do that one. Okay, this says Jorge had to pay $8 to get into the amusement park, so that's a one-time payment that he did. And then once in the park, the rides cost him 50 cents each. So that would be paid per ride, right? So which graph would be used to represent this relationship? So I would actually write my equation out. So it's $8 to get in, and then 50 cents each ride. So you do 50 cents times each ride, so if X is how many rides, and then it cost him $8 just to get in. So there's my equation. So to figure out some points, we could kind of make our table, our XY table. So we know if he rides 0 rides, and we put a 0 where the X is, it's just going to cost him the $8 to get in. If we ride 1 ride, or he rides 1 ride, it'd be 50 cents times 1 plus that $8 he had to get in. So it'd be $8.50. If he rode 2 rides, it'd be 50 cents times 2 plus the $8. So 50 cents times 2 is $1 plus the $8 would be $9. So based on these 3 points, I can look at my graphs. So looking at F, so basically I need 0, 8, 1, 8, 50, and 2, 9. So 0 would need to go with 8. So here's 0, 8. So is that point there? No. So we know this one's not going to work. So then next one. 0 rides, it still cost him $8. So right here, 0 should be up at $8. Because our X was how many rides? So we know that this one isn't going to work either. So the next one is 0, 8, right? So 0, 8. So that one's there. My next point was 1 ride cost 50 cents plus that $8 to get in, so it needs to be $8.50. So it would be between the 8 and the 9, so that one looks good. So 2 rides would be $9, so that one looks good. So it's basically increasing by 50 cents each ride, so this graph looks really good. So I'm going to hold on to that one for now. This one actually, without even looking at them, it's going down. So it's basically saying the more rides he rides, the less it costs. Well, I've been to the fair enough times to know, and I love carnival rides. It's kind of one of my little secrets there, but they're exciting because you know that they put them up in like 5 minutes, so you could fall off of it at any time, which is kind of a thrill on its own. But anyways, you know it costs more depending on how many rides you ride, like tickets or whatever, you have to buy tickets, or you get like a sweet wristband. So anyways, you know this one's not going to be it, because you know it's not going to cost him less money. They're not going to pay him to ride rides. So our answer is H. Next question. Caroline used the following formula to determine T, the sales tax, on P, the dollar amount. So T stands for the tax, and P is the purchase, okay? And they actually gave us the equation, which is awesome. The customer bought a box of red candles for $25 and 4 scented candles for $35 each. So this each is a big word. Which is closest to the sales tax on the customer's purchase? So we're looking for T. So we have to put something in for P. Well, we have to figure out how much is this purchase. So the box of red candles is $25. And then they bought 4 candles for $35 each. That means we have to add the $35 4 times. Or what would be an easier way of doing that would be 25 plus 4 times 35. These mean the same thing, right? Because we know that addition and multiplication, it's kind of the same. So look at this fun pointer. It's like a lightsaber. I can't do that. It's going to be distracting to me. Okay. So anyways, we need to solve this now. So 4 times 35. So I do 35 times 4, 140, plus 25 is 165. So this is not the tax, it's not the t. That we just found is going to go where the p goes. So we need t equals 0.0825 times, because we know we're multiplying, because right next to each other means multiply, 165. So now, to solve for t, we have to multiply this, 0.0825 times 165. So I'm going to blow this up just a little bit. 10, 12. Okay, so we got that. Then I have my 0, because I'm done with my 5. So now I have 2 zeros, because I had 2 places that I'm done with. I think a lot of you forget that. It's just my observation. Okay, so then I have to add it all up. Okay, so now I'm not all the way done because I have to count how many decimal places do I have. So that's 1, 2, 3, 4. So I have to start right here, 1, 2, 3, 4. So this is where my decimal goes. So my tax would be 13.6125. So if we rounded that to make it look like money, it would be 13.61. Remember, because I'd be rounding to this place, I look next door, 4 or less, let it rest, so this 1 stays a 1. So this is my answer on that one. This question says the number of pounds Felix weighs, F, so this F is for Felix, is 70% of the number of pounds Thomas weighs, which is T. So F is for Felix, T is for Thomas. The relationship between their weights is expressed in the equation below. It's so nice when they give us the equation. Thomas weighs 140 pounds. What does Felix weigh? Well, Felix is F, Thomas is T. So Thomas is 140, so we're going to put that 140 where that T goes. So I'm going to rewrite it, but instead of T, I'm going to replace it with 140. So now, right next to each other means multiply, so I have to multiply 140 times 0.70. Remember, when you multiply, you don't have to line up the decimals. So I know I'm going to have zeros all the way across on this one, so then I can cancel that out and just have my 0 placeholder. Then I do 7 times 0, 7 times 4, 7 times 1 plus 2. Okay, so now I have 2 decimals, so I'm going to go 2 decimals there, so I get 98. So my answer is 98 pounds. Remember, that is the abbreviation for pounds. The next one is very similar. Jill's weight is 65% of her mother's weight, M. So in this case, J is for Jill, M is for mom. Jill's weight, so this is the equation. If Jill's mother weighs 125, how much does Jill weigh? So instead of the M, we're going to replace it with the 125. So I rewrite it, J equals 0.65 times 125. So that means I need to multiply 125 times 0.65. So that's 25, 12, 6. Done with those, and I'm done with the 5. So then the last step is there's 2 decimals, so I move 2 times, so my answer would be 81.25. The next part, we get to solve some equations, which is super exciting. So I'm going to zoom in. In this equation, we have variables on both sides. So the first thing I do is draw my line down my equal sign. And I try to decide, I'm going to go and do this just to remember that's the question number, not part of my equation. We need to get our x's on one side and our numbers on the other. So I want to put my x's on the left side. The reason I'm going to do that is because I have a bigger amount of x's on the left than on the right, so it's easier for me to move that to the other side. So that's the first thing I'm going to do. So right now, this x is a positive x. I know that because there's no negative sign in front of it. And every number has to have an operation with it, whether you see it or not, and it's the operation that's in front of it. So that is a positive x. This minus goes with the 5. It's the operation in front of it. So to move the x to the other side, I'm going to do the opposite operation, which is subtract x. So when I do that, that cancels out, so I'm moving it to the other side. I can only subtract it from the other x though, because remember we can only subtract x's from x's and numbers from numbers. Just it's like apples and oranges. We can't mix those together. So when I subtract this, I get 2x, because remember that's standing basically for 1x. So I bring down my plus 4 and I bring down my negative 5. So my next step is to move this 4 to the right side, because I want to get my numbers to the right side. So I deal with these numbers that are hanging out by themselves first, and then later I'll deal with this number that's right next to the variable. So my operation in this case is positive, so the opposite is negative. So I subtract that 4, that cancels out. So what I do to one side of the equal sign, I have to do to the other side. So now I have negative 5 minus 4. So this is where those integer rules come in, and I still see a lot of you struggling with it. The way I think about it is I borrowed $5, so this is I borrowed $5, then I borrow $4 more. So now how much do I owe? So I owe $9. Another way you could look at it, we used to write it like this, negative 5 minus 4. This is where you guys did keep, change, change. So you did keep, change, change. And then you sang the song, same sign, add and keep, different sign, subtract. So these are the same sign, so you add them and you keep the sign. So either way you do it, you get negative 9. I didn't do anything with this 2x yet, so I just bring it down. So now's the time I need to get rid of this 2. So to get rid of the 2, I have to think about what operation is happening between those. So right now they are multiplying, so I have to do the opposite of multiply, which is divide. So I divide by 2, that cancels out. So I'm going to divide by 2 on this side. So I get x equals, so I have to do negative 9 divided by 2. So first of all, I'm just going to think what sign is that going to be. So I know Mac Daddy, this is what you guys did. Mac Daddy, I have a negative and a positive. So I'm going to have negative and positive, so that means my answer is going to be negative. So I'm going to already write that negative sign because a lot of you guys forget to do that. So now 9 divided by 2. Remember, I do it that way because the top one goes in the box. So that's 4 times. I need to add a decimal and a 0, bring that 0 down, bring my decimal up. 2 goes into 10 5 times. So my answer is negative 4.5. Next one. Same thing. I'm going to draw my line down my equal sign. I'm going to look at my x's. I have x's on both sides. Which side has the bigger x? This side. So I like to move mine to the left side. It doesn't matter, you can move it to the right side if you want. I like to move mine whichever is bigger. So right now this is a positive 5x. So because I'm going to move the entire 5x, so I look at what sign's in front of it. If I just divide this 5 right now, I would only move the 5. So I want to move the whole thing, so I look at the operation in front. So I'm going to do the opposite of add, which is subtract. So I'm going to subtract that 5x, so that cancels out. So what I do to one side, I have to do to the other. So I have 2x. I bring down my minus 7, and I bring down my positive 13. So now I want to move my number to the other side. So right now it's minus 7, so I'm going to do the opposite of that, which is plus 7. So that cancels out. So what I do to one side, I have to do to the other. So that gives me 20. I didn't do anything with that yet, so I'm going to bring it down. So now is the time I'm trying to get rid of the 2 that's right in front of the x. So now I have to think what operation is happening right here. So that's division, multiplication. So I need to divide to move it. So divide by 2. That cancels out. It makes a big 1. So I need to do that to the other side. So I'd be left with x equals 10. Remember, you can always check these by plugging the 10 back in where the x's are and making sure that you get an equal statement on both sides. Number 17, we're going to draw our line down the equal sign. This time I'm still just going to move my x to the left. You don't have to, but it'll help us have a positive x that way. So right now I want to move this entire 3x, so the operation in front of it is subtract. So the opposite of that is adding. So I'm going to add 3x, so it cancels out. I'm going to add 3x over here. So this is like saying minus 1x plus 3x. So if I borrowed $1 and then I paid you back $3, how much ahead am I? Or you could write it like minus 1 plus 3. So you do different signs, subtract, keep the sign of the bigger one, so that would be positive 2. So you have positive 2x, so you bring down the minus 3 and you bring down the 1. So at this point, I want to move this number to the other side. So in order to do that, I do the opposite sign. So right now it's subtracting, so I'm going to add 3. So that cancels out. So what I do to one side, I have to do to the other. So I get 4. I didn't do anything with this yet, so I bring it down. I have 2x equals 4. So now I want to get rid of the 2. Right now it's multiplying, so I'm going to do the opposite of multiply, which is divide. So I divide by 2. That cancels. I divide by 2 over here, and I get x equals 2. 18. I'm going to draw my line down my equal sign. My x is actually bigger on the right side, so I'm going to move this x to the right side this time. So right now the x is positive, so I'm going to subtract it to move it. I'm going to subtract 1x on this side as well. So I would get 6x. I haven't done anything with the 17 yet, so I bring it down. And I didn't do anything with the minus 13 yet, so I bring that down. Now I want to move the minus 13. So in order to move it, I have to do the opposite sign, which is plus. So I'm going to plus 13. So that cancels out. So I'm going to plus 13 over here. So that's going to be 30. And I didn't do anything with this yet, so I bring it down to 6x. So now this is saying 6 times x. So to move it, I do the opposite, which is divide by 6. So that cancels out. So I have to divide by 6 over here, so I get x equals 5 on that one. Number 19. I'm going to draw my line down my equal sign. This one, I actually only have an x on the left side, so I'm going to move this number to the right side. To move it, I do the opposite sign, which is add. So it cancels out, so I do plus 7 over there. So again, this is one of those times where it's crucial about our integer rules. Negative 24 plus 7. The way I look at this is I borrowed $24 and I paid $7 back. How much do I still owe? So I still owe 17. I didn't do anything with this yet, so I bring it down. So negative 8x. So I need to get rid of the negative 8. Well, right now the negative 8 is multiplied with the x. So in order to move it, I have to divide by negative 8. Because I want to get the negative sign away and the 8 away. So this cancels out, and those go away, they cancel out. So I'm left with x on this side, but what I do to one side, I have to do the other. So I'm dividing by negative 8. So I know, because of Mac Daddy, that if I have a negative and a negative, my answer is going to be positive. So I already know my answer is a positive something. So I have to do 17 divided by 8. So 8 goes into 17 twice. I have to add a decimal and a 0 and bring it down. It goes in once. Bring down another 0. It goes in twice. Bring down another 0. And that goes in 5 times. So my answer is positive 2.125. So there's that. Next page. So on this one, I have one more equation I get to do. So I'm going to draw my line down my equal sign. My x is on the right side this time, so I'm going to move my number to my left side. So right now it's a positive 5, so to move it I do the opposite, so I subtract 5. So what I do to one side, I have to do to the other. So it's going to be 4, and I bring down the 3x. So now I need to get rid of this 3. Right now it's multiplying by the x, so I need to divide by 3. That cancels out. So what I do to one side, I have to do to the other. So I'm left with x equals 4 divided by 3, which is, I'm going to bring down that 0. Then guess what's going to happen? It's going to be a repeating 3. So 1.3 repeating. Or you could have actually left it as the 4/3. Just a side note, when we do math we can't do math with repeating decimals. So if I ever asked you to multiply by this 4/3, you would actually want to leave it as the 4/3 instead of changing to a decimal, so you could actually solve the whatever it was we were doing. Now we get to write an expression. So that means we're not solving for anything. We're just literally writing the expression using numbers and a variable. So this is the difference of, so difference tells us we're going to subtract difference of 8 and the product, which means we're going to multiply 15 and a number u. So I'm going to do 8 minus, now I have to write the product of 15 and u. So there are several ways you could write it. Some of you write 15 times u. Some of you write 15 parentheses u, 15 dot u. But really with this, all we have to write is 15 and then u, because when it's right next to each other, that tells you already to multiply. I do not really like this one at all, because that times looks like an x. So that's super confusing, and so you should get out of the habit of using that one because of how confusing it is with the algebra. Number 22 says 3 times, so I know we're going to times, the sum of, so it tells me we're going to add something, the sum of 45 and a number q. Well, you want to do 3 times the answer of the addition problem. The only way to do that is to use parentheses, so you do 3 times the sum of 45 and q. And I always make this cute little tail whenever I use a q, otherwise mine ends up looking like a 9, and then it's super confusing. Next one, the quotient of 13 and a number b. So quotient tells us we're going to divide, so we're going to do 13 divided by b. 24, number r divided by 4, so r divided by 4. And then 25 is 26 times the number d. So 26 times d. Decrease by means we're going to subtract 48. And that's it. So good luck studying. We'll see you in class.